Lesson 332 is actually one of my favorite lessons. It doesn't start as one of my favorite lessons, but it quickly turns into one of my favorite lessons. So it starts with some more problem solving by rewriting, and this is a conversation I always hate to have because it confuses kids so much. So Fraction Busters, today you will continue to solve complex equations using the three methods: rewriting, looking aside, and undoing. You will focus specifically on equations with fractions. As you solve these problems, look for ways to connect today's work with what you've learned previously. So more solving by rewriting. Sean gets this problem. He says, I hate decimals, or whatever he says. I think we can get rid of it. Do this problem without decimals. Just multiply everything by 10 and get rid of the decimals, right? So here's the question. If we're going to rewrite this by getting rid of the decimals, is this going to be option A or option B? Option A is we say 0.4 x minus 2 equals 3.4 minus 0.2x, right? Option A is going to say I'm going to multiply everything by 10. So I'm going to get 4 times 10x minus 20 equals 34 minus 2x. Or is it option B, where you're going to say 0.4 x minus 2 equals 3.4 minus 0.2x, and you say, look, this whole thing is one chunk. I'm just going to multiply this by 10, the whole chunk by 10, and then by 10 by 10, and I'll get 4x minus 2 is equal to 34 minus 2x. And this has just been an age-old question that has just confounded kids. They don't know if it's option A or option B, or they think it's A and they're sure and they're wrong, or they think it's B and they're sure and they're wrong, whatever. So let's talk about this real quickly. So what if I gave you a problem like this? What if I didn't have any unknowns and I just said 3 plus 7, and I said, you know what? I want you to multiply this by 10 and make this 10 times bigger. Would I say 5? Would I multiply the whole chunk? Actually, I'm sorry. Let me go consistently. So let me do option A first, where I multiply each piece of it, right? Each piece of this I'm going to multiply by 10. Would I say 5 times 10 and then 3 plus 7 times 10? So I said it's going to be 50 times 30 plus 70, right? Well, that would give me 50 times 100, which would be 5,000. And you can see originally it's just 5 times 10, it's just 50, right? So I go from 50 to 5,000. Is that 10 times bigger? I think that's 100 times bigger. And the reason why it's 100 times bigger is because I multiplied by 10 here and here. I multiplied by 10 twice. That's actually 100. Whereas if I go over here and do it this way, if I say it's 5 times 3 plus 7, but I'm going to only just multiply the whole chunk by 10, so it's going to be 50 times 10, I get 500, and there you go, it's 10 times bigger. So actually option B is the one that we should choose. It may not seem obvious, but if you multiply here and here, remember, this is a monomial, guys, back from earlier videos. This is one piece. Even though you see this minus 2 in the middle, it's all one piece because they're multiplying. So if you multiply it by 10, you're really multiplying by 100. Here, if you just multiply the whole chunk by 10, you're only multiplying by 10. So hopefully you can see with real numbers why option B is the one that we're going to choose. So having said that, let's go ahead and reopen this document, and let's solve this using the option B way, which is where I say, all right, I'm going to go ahead and I'm just going to multiply this chunk by 10. By the way, if you're confused right now, don't feel bad. There's tons of kids that are confused by this every year. In class, we often have like 15-minute conversations where kids swear that their junior high teacher taught them that they were supposed to multiply by 10 here and here. I'm telling you, your teacher didn't. There was some confusion somewhere, some way. But the bottom line is this is going to be 4 times x minus 2 equals 34 minus 2x. So if you want to talk to me in class or reach out via email or whatever you want to do, if you're still confused by this, we could talk about it more. So I will get 4x minus 8 is equal to 34 minus 2x. I'll add 8 to each side. I'll add 2x to each side, and I will get 6x equals 42, x equals 7. Again, if I did this right, it should work out fine. So 7 minus 2 is 5. 5 times 0.4 is 2. So 2 should equal 3.4 minus 1.4, which is 2. So there we go. We're pretty confident on this answer. It looks good. So it says rewriting 0.4, blah, blah, blah. I gave you at least one new equivalent equation that was much easier to solve. So multiplying by 10 got rid of the decimals. So 2 equations are equivalent if all their solutions are the same. There are several ways to change one equation into a different equivalent equation. In common ways including adding or subtracting the same number from both sides, or multiplying or dividing both sides by the same non-zero number. So rewriting an equivalent equation for each equation below, make sure that your equivalent equation has no fractions or decimals. So on this one, it seems like I want to multiply by 10, right? But it looks like I actually have to multiply by 100, which is kind of a pain. So we're going to multiply every term here by 100. And again, there are no like sort of compound terms. So we're just going to say negative 7, move the decimal twice, 750x squared plus 480x minus 30 equals 250x squared plus 1002 minus 1000x squared. It's supposed to be 1000x squared. Sorry, I ran out of room there. So if we look at that, I get negative 750x squared. By the way, this problem I disagree with in the book. I don't think this is any easier than doing it with decimals. Like, if you agree with me, great. If not, that's fine. But every time I do this problem every year, I get so annoyed. All right, so minus 1000x squared plus 250x squared is minus 750x squared plus 1002. I will add 750x squared to both sides. I will add 30 to both sides. So I get 480x is equal to 1032. I'll divide both sides by 480. Is this really the problem? There's got to be an error here, doesn't there? 1032. I know this problem's a nightmare, but this seems so wrong. I get 2.15. So x equals 2.15. So let me pause this and see if I didn't screw something else up. I think I had a lot of trouble focusing right there. I don't know if you could hear on the video, but my wife and daughter were talking in the background, and it seemed loud. I don't think they were angry, but they are loud talkers like I am, I guess. They accuse me, but they are too. So let's go ahead and divide by 100 on these. Actually, let's divide by 1,000, right? Let's get rid of 3 zeros. And again, just like the lesson we learned up here, I only need to multiply by 10 once for this whole chunk. We only need to divide by 1,000 once for this whole chunk. So it's actually going to be 2x minus 24 plus 5 equals 18. And I'll say, yeah, B is really worth rewriting. A, I don't think really helped too much. So I can subtract 5 from each side. I'm going to get 2 parentheses x minus 24 is equal to 13. I'll divide by 2. So I'll get x minus 24 is equal to 6.5. I guess I don't really need this here. I'll add 24 to each side. And I'm getting x equals 30.5. So again, let me jump over real quick and make sure, just because I'm not used to this book giving us so many answers that don't work out evenly, but there you go, there's our 30.5, so it worked out fine. All right, so solving by undoing, look again at part B of problem 3, 121. After we rewrote the equation, you also used undoing by solving it. Explain how you used undoing when you solved. Well, it was multiplying by 2, so I divided by 2, and it was subtracting 24, so I added 24. All right, finally, we're through the part I don't like of this lesson, and we are to the part that I love, fraction busting. I hope you feel comfortable with fractions. The more comfortable you feel with fractions, the easier the rest of your math career is going to be. I will tell you, Mrs. Baldwin, the fabulous teacher you will probably have for Advanced 3 and Calculus, says decimals are dead because you need to be comfortable with fractions. So we need to start getting comfortable with fractions now. And a nice little trick here is this. When you get a problem like this, There's a few different ways that we can go about this. So I'm going to ignore all this stuff here and just sort of talk about fraction busting, at least how I see it. So the two ways that I would look at this problem would be, one, to get rid of the fractions one at a time. And I would say, hey, look, I can multiply this whole thing by 6, because think about it. What is 6 times x over 6? Well, I just get x. So it's beautiful, right? But if I multiply this by 6, I need to multiply this by 6 and this by 6, right? That's just the way equations work. So this is going to cancel out, leave me x. This is going to be negative 30 over 8, and this is going to equal 24. The problem is I still have an 8 here, so I can multiply this by 8 to cancel those out, but again, I need to multiply this by 8 and this by 8. I'll get 8x minus 30 equals, what, 32 plus 160, so 192. I'll add 30 to both sides. I will get 8x equals 222. Divide by 8. And I will get x equals whatever 222 divided by 8 is. And we get 27.75. As a matter of fact, I don't really love that answer. I've already forgotten it. 27.75. I am totally fine and prefer you actually to reduce this, right? Just reduce this. 2 goes in here 111 out of 4 times. So you can also call this 111 over 4. So that's going to be our solution here. Again, we'll run over here real quick just to make sure I got it right. There it is, 111 over 4. So perfect. The other thing is this, though. What if I didn't want to do this in 2 steps? What if I said, hey, look, I know 6 goes into 24 and 8 goes into 24, so I'm going to multiply this by 24 instead of by 6 and 8. So this is going to cross cancel and leave me 4, right? 6 goes into 6 once, and 6 goes into 24 4 times, so I get 4x. Here, I'm going to get 3, so I get minus 15 equals 80, 96. I'll add 15. And there's our 4x equals 111. So x equals 111 over 4, which is 27.75. So again, you have this ability to either go step by step and multiply it twice by 6 and by 8, or you can multiply it by the common denominator. By the way, 6 times 8 is 48. We could have just as easily multiplied this side by 48 and it would have worked out the same. So that's what we're looking at there. Let me open B and see what it looks like. So I just wanted to open the B document because we did these problems and they gave us some more that were kind of cut off at the bottom, and I felt like if I opened this I would have a better idea of being able to see what I was doing. So I'm happy I made that decision because now I have some room to work. All right, so again, let's go ahead and look at these. And again, it's up to you how you perceive this. You can either multiply everything by 2, and you're going to get 10x over 3 plus 15 equals 5. And again, the beauty of picking 2 is it canceled these 2's out. Well, now I need to go back and multiply by 3. So I'll get 10x plus 45 is equal to 15. I'll subtract 45 from each side. I get minus 30. So I get x equals negative 3, of course, once I get done dividing there. Well, let's say that instead we use the common denominator, right? So let's say instead we use the common denominator of 6. 3 goes into 6 and 2 goes into 6. So this will cancel, leave me a 2. So I get 10x. This will cancel, leave me a 3. I get 45. This will cancel and leave me a 3. I'll get 15. There's our 10x equals negative 30. By subtracting 45 from each side, divide by 10, x equals negative 3. So you can see it doesn't matter if you do it in 1 or 2 steps. So on this one, you can even multiply by x. So again, if I multiply by x, these x's cancel. Now I don't have an x on bottom. What I have is minus 2x here and minus 11x over 8. Well, now we'll come back and multiply everything by 8. So I'll get 40 minus 16x equals negative 11x. Obviously, I'll add 16x to both sides. 40 is equal to 5x, so x equals 8. Again, but what happens if I decided that it made more, actually, you know what makes more sense is to go back to the pen and just draw a white rectangle over this and keep going. I think that makes more sense. So what happens here if I decided to multiply this by 8x? Well, the x's will cancel, but I'll have 8 times 5 is 40. Here, nothing cancels. I get minus 16x. Here, the 8's cancel, but I still have that x there, so I get minus 11x. I'll add 16x, and as you can see, I get 40 equals 5x, so x equals 8. So the answer I had already gotten. So this one, same thing. I'll multiply by 2x. And that should get rid of everything, right? That's the common denominator. 2x goes into 2x and 2 goes into 2x. So the 2x will cancel. I get 7. The 2's will cancel, but that x is left behind, so I get 3x equals, here I'm going to double, I get 6.5x. I'll subtract 3x, and I will get 7 equals 3.5x. So 2 equals x. So that's what I'll get. So that's some fraction busting. I'll tell you, muy importante. You want to get super comfortable with fractions. So make sure that this made sense. We're going to do some more with fraction busting. So I would strongly encourage you to be asking questions if you're struggling with it. And by the way, if you're struggling with it, you're not alone. Not everyone is great at fraction busting. Ultimately, it would be better if you were great at fraction busting coming out of junior high, but not everybody's there. So we really want to get it early in high school so that later in high school is easier. Are there any inputs of this problem that we're not allowed to plug? Yeah, I can't plug x equals 0 into here. So x doesn't equal 0 here, and x doesn't equal 0 here. Why is that the case? Well, I can plug a 0 in and have a 0 on top here. That's fine. But if I plug a 0 in here, I'm dividing by 0, and that's not okay. And if I plug a 0 in here, I'm dividing by 0, and that's not okay. So again, that's known as a restricted domain, and you're going to deal with that in integrated 3 and in calc. But just kind of throwing that out there that you're not allowed to have x equals 0. Now you're going to reverse the process of solving equations by rewriting. Your teacher will give your team a simple equation you need to complicate. I'm actually not going to do that, so we're going to call it good.